All right, everybody. So in this video, I'm going to begin the integumentary system. So we're going to do integumentary PowerPoint part one. So I'll do part two in lecture next week. So this is just what we would have covered today if we would have met. So it's probably a good thing that we have a video because you go back and watch it a few times. All right, so we always start with the integumentary system as our first organ system to go through because your integument's pretty straightforward and simple, or some more simplistic than a lot of the other organ systems. So it's a good starting point just to kind of get your feet wet with how the body works. Now we're done with all the tissue, and we've covered all these different types of tissue. What you're going to see is that we're going to see those same tissues just in different proportions for all your different organs of your body. So it's good to know those tissues. So definitely go back and study those. All right, well, when we're talking about the integumentary system, what we're really talking about here is skin. All right, skin is the organ of the integumentary system, and we refer to skin as integument. And if you remember your definition of an organ, it's two or more tissues working together. And you can clearly see there are multiple tissues when it comes to your skin. So we have names for each of these tissue layers that make up your skin. So we have the epidermis, which is the topmost layer. So this is all stratified squamous epithelial cells, if you remember that. And we'll talk about the different layers to the stratification. Below that, we have the dermis. This is mostly made of connective tissue, both areolar. Areolar is going to be towards the top, and it's papillae, and dense irregular, which is going to be the majority of the dermis. And this is where you're going to find most of the structures or appendages to the integument. It's going to be housed in this dermal layer. And then below all that, we have the hypodermis. The hypodermis is adipose tissue, and so just fat storage. This fat's actually really important for your health. A lot of the parts in your dermis need energy, so they're going to get energy from this fat storage, but also does a lot in insulating you to prevent any heat loss or anything like that. So it's a good insulator, and that's why it's near the surface of the skin. All right, so starting with the epidermis in this talk, when we're talking about the epidermis, we're talking about that stratified squamous epithelial cells. So all these cells are keratinized. That means they make keratin. Keratin is a protein that's very fibrous and rigid, and we need this on this very top layer because it's going to help a lot with protection and protecting against a bunch of different things. So we're going to talk about keratin and how these cells are keratinized as we go through each one of these stratum. So there are 5 major stratum when it comes to your epidermis, and actually most of your skin only has 4 stratum, but we do find a 5th stratum in very specific locations. So in order, going from deep to superficial, this is the order. First, we have our stratum basal layer. This stratum right here is that mitotic layer. This is actively going through mitosis, making new cells and pushing cells upwards. After that, we have the stratum spinosum. You're going to start seeing the formation of desmosomes here to really hold all these cells together to make sure all these cells act as one unit to protect your skin or to protect your body. Above that, then we get to the stratum granulosum. This is when you're going to start seeing the cells shrink, and this is when you're going to start seeing keratinization occur, the formation of keratin. And then finally, those cells die, and the only thing that's left is keratin above that. And so we have 2 layers for that one. First, we have the stratum lucidum. This is that 5th layer that's kind of only in certain parts of your body. You usually only see this in very thick skin, like the skins of your hands and feet. It gets the name lucidum because these cells are usually clear in color, so that you could see through them, being lucid. And then way above that, then we have the stratum corneum. The stratum corneum is that topmost dead skin cell layer. This is what's going to slough off throughout the day. This is just keratin left over, and we're going to drop this off constantly. So we constantly have this kind of conveyor belt motion going with these stratum. We create new cells down here, and then we start pushing them upwards. And so as the cells age, as they come closer and closer to the surface of the skin, they're going to start doing different things and eventually die and just leave behind keratin. Okay, so looking at the epidermis, there's really only 4 major types of cells that you find here. The majority of cells are called keratinocytes, which means these are cells that make keratin. So everything that you see here is a keratinocyte because they're going to make keratin. Either they have already made it, which is the topmost layer, or they're about to make it or getting the stuff ready to make it. That's not all we find there, though. We find other cells to a lesser degree. Another cell that we find there is melanocytes. Melanocytes are responsible for creating melanin. Melanin is that pigment that we create to kind of protect ourselves against UV radiation. So those are made by very specific cells, these melanocytes here. But what's interesting though is it's not just the cell that holds on to this melanin. So here's a good little GIF of this happening. So here's a melanocyte right here. It's very dendritic in nature. It looks kind of like a dendrocyte, which is a type of white blood cell. So you're going to make all this melanin, this photopigment, this protein, and package it inside a organelle called a melanosome. And then once that melanosome is made, then that melanocyte will donate that melanosome to the keratinocytes. So actually the keratinocytes will have that pigment in it to protect you. However, they're not making it. It's actually being made by the cell and being donated in this organelle called a melanosome. On top of that, we also have dendritic cells. Here's a dendritic cell here. Dendritic cells are types of macrophages that crawl around your tissue. They are kind of have this star pattern to them, and they're going to kind of squeeze in between all these cells looking for foreign pathogens to digest or any dead cells that need to be taken care of. They'll get rid of them. And then finally, we have tactile cells. Tactile cells are part of your touch receptors. So it's a type of receptor. We'll talk about all the different types of receptors later when we get to general senses, but this one is just a single-celled receptor. So you have these kind of throughout your epidermis, and you're going to use these to detect light touch or things that are touching the surface of your skin. All right, so I'm going to go through each one of these stratum. All right, so first is the stratum basale. That is this bottommost layer, or the most basal layer. That's why we call it that. So here's your stratum basale right here, touching the basement membrane. These are the ones that are undergoing mitosis constantly. So this is made up of a bunch of stem cells, and I'm sure you've heard that term before. A stem cell is just a cell that undergoes mitosis over and over again. So what happens if you start with that parent cell, if you remember through mitosis, you create two daughter cells from that first parent cell, right? Well, with this process, when we go through mitosis, and you have these two cells, one cell will go back and become another stem cell and do that same process over again. While that other cell will go off and start maturing to be a keratinocyte, all right, and then go through the whole process of reaching to the surface of the skin. All right, so that's why we consider them stem cells. So this whole process of creating a cell and then having it go to the surface takes about 25 to 45 days. So we're constantly making new cells through this whole process. This is also the layer where you're going to find melanocytes, so the ones that are responsible for making that photopigment. So here's a melanocyte here. These are the ones going to make that melanin and then donate it to these fresh keratinocytes that were created. So they're going to pass them off. So about 10 to 25% of the stratum basale is made up of melanocytes. And also, this is where we're going to find those tactile cells that are used for reception. So light touch is going to be sensed here as well. All right, the next layer is your stratum spinosum. So your stratum spinosum gets its name because of how we first discovered it. Spinosum means spiny, and it gets its name because all these cells have desmosomes associated with them. If you remember, desmosomes is that junction between two cells that can stretch but recoil and holds things together tightly. Well, during the staining process of this, we have to use alcohol, and those cells will shrink. And when they shrink, those desmosomes stay pointed or sticking out. So it looks like little spikes or spines surrounding these cells. That's where this name's coming from. That helps you remember it. But the stratum spinosum is when things are going to start to develop. So we're past that stem cell stage. We're going to actually start to develop or differentiate into this keratinocyte. We are not yet making keratin. So instead, we're going to make pre-keratin filaments, which is going to be a precursor to keratin. All right, so keratin is going to be made later on, but we need to make these structures first that can be later converted into keratin. These cells are going to grab all those melanosomes that were donated by the melanocytes. So they're going to have tons of pigment in them. And you're not going to find much of anything else here. You're just going to find those stratum spinosum cells. The only other thing that you'd really see here, you won't see tactile cells, you won't see melanosomes, but you will see dendritic cells. Dendritic cells can squeeze through all the gaps that are created with these desmosomes between these cells and kind of work their way through these cells looking for some foreign pathogen. All right, then we get above that, we get to the stratum granulosum. This is a small layer. It's only about 5 cells thick. This is when the cells are going to start getting flat. So they're going to start losing a lot of their organelles. They get rid of their nucleus and a bunch of different stuff because they're about to die before they get to the stratum corneum. This is actually where keratinization begins, where we actually make keratin from those precursors that we talked about in that previous slide. All right, so that is going to be done by a organelle called a keratohyalin granule. So whenever you see granule, we're really just talking about an organelle there. But this whole process is going to happen inside that organelle, not just out in the cytosol of the cell. All right, another organelle that they contain is called a lamellar granule. So this is really important because they're going to make glycolipids, and we're going to secrete glycolipids between the cells. You could probably guess what a glycolipid is. It is a sugar fat mix, okay, of a molecule. Well, we create that because it's going to create a nice little even coat between all these cells that are up here, giving us this kind of barrier that won't let water through. All right, water cannot make it through lipid. So by having this kind of lipid substance that is going through all these cells, we're kind of coating all these cells with this liquid that prevents water from leaving, which is going to prevent desiccation or dehydration. All right, next we have the stratum lucidum. This one is kind of the special one. We only see this in our hands and feet, really. This is where you can find it in really thick skin, usually calloused skin. This is just adding an extra layer of protection. So it gets this name because it's a part of the stratum corneum that is clear when looking at it under a microscope. And you can see it right here. You can see how these cells are much clearer than the cells above it. It's only a few rows thick, but it does add that extra protection. That's why we have this in those very thick skin areas. And then finally, we get to the stratum corneum. This is all dead skin cells. All right, so this could be very thick in some locations, and it will vary depending on what part of the body. But all these cells have lost all their organelles at this point. There's pretty much just keratin left behind and a little bit of the plasma membrane. And this can make up 3/4 of the epidermis thickness. So you can see how much or how thick this layer can really be because it's adding that layer of protection for you. Now, it protects in a lot of different ways. One, it's obviously going to protect against abrasion. That's why we have this whole stratification going on. So if anything gets scraped off, we have new cells right underneath it, so none of the soft tissue that is deeper will be affected. But it's also helping with a lot of other stuff too. So this keratin that's left behind and these glycolipids that we leave behind are going to coat the top layer of your skin and prevent any water from escaping. So water cannot move through this layer, so we're not desiccating. It also creates a biological barrier against pathogens too. So keratin is kind of disrupts the plasma membrane to a lot of bacteria, so bacteria can't grow on it very easily. And it's also really resistant to acids and bases, so keratin can prevent those things from attacking it. So, and that's kind of how bacteria like to enter different tissues. They'll release some sort of chemical that's either really acidic or really alkaline to get into that soft tissue. Well, since keratin is resistant to these things, it prevents those bacteria from getting in. All right, so I want to talk about a quick clinical real quick that happens in your epidermis, and that is skin cancer. So skin cancer originates in your epidermis, in this stratified layer that we've been talking about. All right, so I'm sure a lot of you know this already, but cancer is just when your cells divide out of control, undergo mitosis without regulation. And that obviously can cause problems because the cells will keep growing and then grow a tumor somewhere. And if it's somewhere deadly, it will be fatal. As far as skin cancer goes, the reason why this might happen, there's really two major factors. Obviously, genetics is always going to be a factor when it comes to cancer, but two environmental factors that could occur is one, UV exposure. If you spend too much time out in the sun, it could trigger this process to start occurring. But also smoking has been linked to skin cancer. I know a lot of times people associate with smoking with just lung cancer, but there is a tie to skin cancer as well. All right, so as far as the different types of skin cancer go, they're really just named based on the type of cell that is dividing out of control. All right, so the first one is called basal cell carcinoma. So you can probably guess which cell is dividing out of control here. It was that stratum basal layer, those mitotic cells that are already undergoing mitosis. Now they're doing it very rapidly and not in a really controlled fashion. With basal cell carcinoma, this is probably the most survivable out of all the skin cancers. It's almost always malignant. In some cases, it's not, so you should always still get it checked out. But for most cases, it's going to be malignant and not spread to other sensitive areas to the body. And it's pretty easy to take care of. You just cut it out and then everything's fine. You got rid of those damaged cells that are dividing out of control, and then everything can go back to normal. All right, the next one is squamous cell carcinoma. This one is more deadly. All right, so squamous cell carcinoma is actually division of the stratum spinosum cells. So these cells are now dividing out of control. This one is not malignant. This has a tendency to metastasize very easily, which means those cells will break off and then move to other parts of the body and then keep undergoing mitosis there. So sometimes you can get this in your lungs. One of the things that happens is if you have a cancer cell that breaks off in your bloodstream, sometimes it gets caught in your lungs and it'll grow there. So when we say lung cancer, that's kind of an open term because a lot of times lung cancer is a different type of cancer that's growing out of control. And sometimes you could have squamous cell carcinoma occurring in your lungs because one of those cells eventually made it there through your bloodstream. But again, these are very deadly because they spread so easily. And so preventative measures is really important for stopping these. Now, the most deadly is melanoma, and melanoma is uncontrolled division of your melanocytes, those cells that make melanin. All right, this metastasizes very easily, much faster than the squamous cell. And so this one, because it's so deadly, early detection is the only way to survive it. So we kind of have to make sure they're always following this ABCD rule to check people to see if anything is happening or if they have this occurring in them. So you'll see this in a lot of dermatology offices. So ABCD just stands for asymmetrical, border, color, and diameter. People have added this evolving thing later on, but usually we're looking for this first and for as an early sign. This is if we keep monitoring it over time, that will also occur. So A standing for asymmetry, that means if you have a dark spot growing on your skin that is not round, not perfectly round, but it is dark and it kind of has, lumps growing off of it, or just it's not a perfect circle, that's something to be concerned about. That could be a sign of just uncontrolled division. You also want to look at the borders of it. So a lot of times, just moles will have a nice smooth border around it. That doesn't happen with a melanoma. Melanoma will have a very jagged border to it. All right, so that's something else to look for. Color obviously is really important because these are melanocytes that are dividing out of control. They're going to be very dark in color. And a lot of times they'll cause bleeding too. So you're going to have this kind of dark scabby look to it. All right, and then finally diameter, it matters too because these grow so fast, they usually grow in size really quick. So anything greater than 6 millimeters that looks like this is a reason to be concerned. All right, so that's it for the epidermis. Moving on to the dermis now. So this is your connective tissue layer. Again, this is where you're gonna find most of the parts to skin. We'll talk about all that in the second PowerPoint. But for now, we're just talking about generally what's going on with the dermis. All right, so your dermis, again, is mostly connective tissue. And two major types. It's going to be a dense irregular connective tissue, and it's going to be areolar connective tissue. So we divide our dermis into two major layers. So the majority of the dermis, this deeper layer right here, we call the reticular layer. This is going to be that dense irregular connective tissue layer. Now above that, though, kind of going into the epidermis, we have the papillary layer. So papilla means nipple in Latin, and it kind of gives these little nipple appearances right here. It's just extensions of the dermis being pushed into the epidermis. So you have this little nipple right here. That is going to be made of areolar connective tissue. So you have a lot of stuff going on in your dermis, obviously. This is where you can find all your glands, your oil sweat glands, your hair follicles. You have tons of macrophages running through all this extracellular matrix that this connective tissue made. You have obviously going to have fibroblasts there for the areolar connective tissue. You're going to have mast cells here. If you remember, mast cells is a special white blood cell that causes inflammation. So this is the layer that usually becomes inflamed during inflammation, where edema is going to occur. You're also going to have tons of blood vessels running through here. It's very vascularized. And you're going to have tons of lymph vessels running through here too, because this is kind of your first line of defense with bacteria coming in. All right, so looking at that papillary layer, so this is papillae right here, these little nipples, and you see it does kind of look like little nipples. It kind of looks like that that foam packaging that you get sometimes, and it fits together very nicely with your epidermis that way as well. This is vascularized. There's going to be blood vessels running up and through here. And again, it's made out of areolar connective tissue, and you're going to have a lot of receptors being found here. So we'll talk about receptors when we get to general senses, but a lot of the touch receptors will be found here. Now, that's not including those tactile cells we talked about in the epidermis. There'll be other receptors as well for touch, not just those. You also have white blood cells running through here too, because again, if bacteria can make it through that first barrier of your epidermis, then you're going to need those white blood cells to take care of it. And so yeah, we have a bunch of different stuff going on at this layer. Now, that is making up a very small part of the dermis. The majority of the dermis is actually that reticular layer, which is made up of dense irregular connective tissue. Now, if you remember, dense irregular connective tissue has collagen fibers that are running kind of all different directions, so it can withstand stretch in all different directions. However, there is some uniformity or direction to those collagen fibers. All right, so it's not just perfectly random scattering. There is some direction to it, and that directionality usually goes in the length of common stretch of your skin. All right, so just to give you an example, so you have collagen fibers in your legs that run straight down the top part of your femur. Well, that's because when you're moving your legs, a lot of times that skin there stretches. Like if you flex your knee, the top part of your skin will stretch that direction. So you want that extra protection. So most of the collagen fibers would run that direction. So we have a term for all this directionality to our collagen fiber. We call these cleavage lines, and you may have heard of them before. So here's a good map of cleavage lines in the body. This is actually really important, especially for surgeons, because it actually took us a long time to realize this. But if you get a cut that is perpendicular to those cleavage lines, that cut is usually actually way worse than it would be unless you went the same direction as those cleavage lines. And I want you to try to imagine why this might be. All right, we have these collagen fibers running a certain direction in your skin. Okay, if we make an incision in surgery that is parallel with them, all right, you'll split them open without actually cutting those collagen fibers. Okay, so that's actually going to make a smaller cut. But if you cut perpendicular to that, remember these collagen fibers have a lot of tension on them. So if you cut between them, those collagen fibers will spring back and actually open the wound even more. So one of the things surgeons need to do before they can finish med school is actually learn all the mapping to your cleavage lines. All right, they also it's not just collagen fibers, they also contain tons of elastic fibers in this tissue too, which makes sense because your skin is constantly stretching and recoiling as well. Okay, so that's it for dermis and epidermis. We're not going to spend too much time on the hypodermis. Remember, it's just adipose tissue, so there's not much going on there. So now we're going to just talk about important factors to your skin, because your skin actually is a really important diagnostic tool. People tend to change color in their skin depending on what's going on with their body. So understanding why skin color happens the way it is can help you diagnose illness in the future. All right, so as far as skin coloration goes, there's only three major factors that give your skin color. One is melanin, all right, that photopigment that we create, or that pigment that resists UV radiation. Two is carotene. Carotene is a nutrient that you get through your diet, and depending on how much of this nutrient you have will depend on the color of your skin. And then also hemoglobin in blood. Blood is red, right? Well, that's because of the hemoglobin there. So because there's so much vascularization, especially in your dermis, you have more of this red pinkish color or undertone to your skin. And that could also be a very good diagnostic tool, because it'll tell you if you're having issues getting blood to your skin or not. All right, so I'm going to start with melanin first to understand skin color. Now, if you remember, melanin is created by melanocytes that are packaged in melanosomes that are donated to the keratinocytes. All right, well, there's actually two types of melanin. It's not just one type. So we have something called eumelanin and a pheomelanin. So everybody makes those two pigments, all right, and we need both to kind of cover the whole spectrum of UV radiation that we need to protect ourselves from. So eumelanin makes more of a black-brown pigment, while pheomelanin makes more of a yellow-reddish pigment, okay? Now, what's interesting, though, is what makes everybody unique and different as far as skin color goes and your eye color and your hair color. It's just the proportions of these. Again, everybody makes eumelanin and pheomelanin, but it depends on the ratio of each that you make, and how much of each that you make will make this variation in skin color and hair color that we see in the world. But again, it's really important for UV radiation, so we need to make this. It is very important, actually, and typically if you spend more time in UV radiation, you're going to make more of it, and that's what tanning is. We get darker in color in order to try to protect ourselves more from this constant exposure to this very deadly factor. All right, so that was one big one is melanin that adds to skin color. Another one is carotene. Carotene is a nutrient. It's actually a precursor to vitamin A, and you use vitamin A for a lot of different stuff in your body. It creates this kind of yellow-orange pigment, and you could actually change the color of your skin and become a more kind of an orange color based on your diet. So a lot of times, if people eat a lot of carrots, they will actually get this kind of orange glow to their skin because of this carotene that is in carrots. So we have a term for that. It's called carotenemia. So you can see that here, this person had a high carrot diet, and you can see that they had a little bit more orange undertones versus this person that is more kind of a pink undertone because of the blood that is running through their skin. All right, and then finally, the last thing that contributes to it is hemoglobin from your blood. All right, hemoglobin is a protein that is found in red blood cells. It's why your blood looks red. And we have high vascularization in our skin, so our skin kind of has this kind of reddish pinkish color to it because of the blood that is flowing there. Now, that blood is usually only red when it's oxidated, or oxygenated, I should say. So that could give a clue to if somebody's having trouble with getting oxygen to their tissue, because if their blood, or if they don't have this reddish undertone, if it looks more blue in color, that actually means they don't have oxygen in their blood, and which could be a sign of something serious. All right, so using skin color as a diagnostic tool. So there's going to be terms that you'll see throughout your career on just referring to different things that could go on in the body based on what is happening with the skin itself. All right, the first one is called cyanosis. Cyanosis is a blue coloration because of low oxygenation of your skin, or of your blood that is running through your skin. And this could be a sign of a serious condition. This could be a sign that your respiratory system isn't working properly, or your heart is not working properly, and you're just kind of burning through all your oxygen before it can get to all your tissue. And if oxygen can't make it to all your tissue, you're going to start having tissue death. All right, so usually we see cyanosis first occur in the fingers and toes of the body. So you can see it happening to this individual here. Their fingers are turning very blue. That's because there's low oxygen making it to their extremities or the very tips of their fingers. All right, so that is a reason to be concerned. The next one is erythema. This is kind of a reddish, a really bright red coloration to your skin. So there's a few reasons why this can happen. We do this naturally too. Sometimes if we're ever feeling embarrassed or if we're sick with a fever, a lot of times we'll get this kind of red flushed look. But it could also be a sign of inflammation or hypertension too. So both of those can be serious conditions. So it's just something to keep in mind. Here's an example of erythema. Here you can see the blood vessels here got really inflamed with blood and becoming more red. All right, the next one is called pallor, which is when you're pale. All right, pallor happens because you have lost blood to your skin, which can happen. All right, our skin is a reservoir of blood since it's so vascularized. And a lot of times your body, if it needs blood in an emergency situation to other organs, it will take it from your skin. And when that happens, you'll become pale because you've lost that underlining hemoglobin color to it. All right, so here's an example of pallor right here. So here's somebody with ruddiness. Ruddiness means kind of just natural red coloration, that red undertone. Here is the pallor going on. You can see how this person has kind of lost that red undertone. All right, next special case is jaundice. You may have heard of this one before. So jaundice is different. Jaundice is a yellowing of the skin. This is not because of carotene. This is actually because of something called bilirubin that you have in your blood. So bilirubin is what's left over of your hemoglobin when you break down your red blood cells. So we're constantly kind of making bilirubin, and we usually excrete it through our feces. So our liver will collect all this bilirubin for our blood and add it to our feces, and that's actually what makes your feces brown, is all that bilirubin. However, if you have liver damage or if your liver is failing, that process shuts down and you start accumulating all this bilirubin in your body. And when you accumulate it, it actually turns your skin a yellowish color. You also see this yellowish in their eyes. The white part of their eyes will turn really yellow. And this is usually a sign of liver failure, which could be a serious condition. And then finally, we have bruising. So bruising, I'm sure everybody's had a bruise before. It really is just clotting happening underneath the skin. Remember, we have this whole clotting process that occurs if we ever have an open wound to stop any bleeding from happening. Well, it's not just limited to open wounds. It could happen under the skin too. So that's really just what bruising is that whole clotting process without the open scar or open wound. All right, so that's everything I need to talk about for integumentary system part 1. So I'm going to start with integumentary system part 2 when we get to next class. I know I went pretty quick with this, mostly because I know nobody can ask questions because this is a video. But I'll definitely make sure, and I'm confident that we will have extra time before exam one for anybody to come in and ask questions in lecture. All right, I hope everybody's staying safe. It doesn't look like the storm's going to be too bad for us, but you never know. So just be wary of your surroundings and what's going on with the storm. And I will see everybody on Wednesday. All right, thank you.